All right, guys, let's try number one. Okay, so what we're going to be doing is filling all this stuff in and including graphing any information that we have. Okay, so first thing we are given is our equation, our function in standard form. And our first thing we need to do is put our equation in factored form. So this is something we've done over and over again. As a reminder, when we put an equation in factored form, we want to factor it. Okay, so our job here is to factor our standard form of the equation. So we're going to factor this bad boy. How do we factor? You should be pretty comfortable with these factoring methods now. Okay, if not, you need to get help from me. All right, so GCF, X method, and snowflake method. All right, so let's look at what method will work here. GCF would not work because there's nothing that divides these. Since this is a power 2, it's called the quadratic pattern, which, if you recall, we have an A, a B, and a C. And this is the case when you have a power of 2. You'll have an A, B, and the C. Okay? Sometimes you'll see a quadratic pattern where the B is missing, and we put 0 for the B. Okay? But in this case, because my A value here is 1, that means we are going to use the X method. All right. So again, I'm assuming you know how to do these three methods and when to use them. Okay. If not, please get help. So the X method is A times C on top. That's going to be 1 times -3. That's -2. B goes on the bottom. That's +2. Okay. What multiplies to -3? That adds up to 2. And that's going to give me 3 and -1. Okay. 3 times -1 gives me the top number, -3. 3 plus -1 gives me the bottom number, +2. Once you have this, we can go ahead and put it into factored form. So we have f of x, because it's still in function form, equals, and then we put it into factored form, which is going to be x plus 3 and x minus 1. All right? So now we have it in factored form. We are done with that second question. X-intercepts. Okay? X-intercepts are where does my graph cross the x-axis? All right? So x-intercepts, another way we're going to figure this out is we're trying to find the zeros. Another word for this is we're trying to find the solutions. So in other words, we are solving for our function, okay? And the best way to solve is, if it's in factored form, set these factors equal to 0. So we are going to do that. So factored form is x plus 3, and again, you've done this before, x minus 1, set them equal to 0, and split. Okay, set each factor equal to 0, and let's solve. So we're going to subtract 3 here. Okay, x equals -3, and then we're going to add 1 here. X equals +1. So these are your solutions. But what we want to do is turn them into x-intercepts. X-intercepts are always in ordered pair form, okay, or point form. So when we write our x-intercepts, we put it in ordered pair form. Again, that sounds kind of complicated, but it really isn't. We're putting it in point form. So our x-intercepts always want to go in x, comma, y form. So if you look at our x-intercepts, we have 2 of them. Our x value in the first one is -3. So our first x-intercept is -3. Okay? And every x-intercept has a y of 0. So that's one x-intercept. Our next x-intercept is 1 with a y of 0. So the rule here is x-intercepts, y will always equal 0 on the x-intercepts. Okay, so I'm going to actually graph those, -3, 0. And 1 comma 0. Okay, so we have that. All right, so those are my x-intercepts. Now we want to do the y-intercept. So the y-intercept is the opposite. When we have the y-intercept, our x will equal 0, okay? As far as a graph goes, our y-intercept is a point on the y-line, our vertical line. So how do we find that? It's pretty simple. We're going to plug in x equal to 0 into the standard form. Equation, okay? So that's equation, EQN, equation. All right, so we're going to take our standard form, and instead of f of x, we're going to change it into y, okay? Because f of x is just y value. Just another way of saying y. So y equals, instead of x, we are plugging in 0 for x. So it's going to be 0 squared plus 2 times 0 minus 3. Now let's do this math. 0 squared is 0. 2 times 0 is 0. And then bring down the negative 3. If we do this math, y is equal to negative 3. So we found what y is equal to, but just like before, our y-intercept has to be in ordered pair form. Same thing. So we want to put this in ordered pair form. So it's ordered pair form. And we always know when we have a y-intercept, x is always going to be 0. So our x value is always going to be 0 when we have a y-intercept. And our y value in this case is negative 3. Okay, so I'm going to plot that. It should be on this. So we go 0 on the x, but down negative 3. Okay, so we have these 3 points. Okay, so let's go on to this next section. Point symmetric to the y-intercept. Symmetry means it's the same on the left as it is on the right, okay? We cannot answer this until we find our symmetry line, which is called the axis of symmetry. The axis of symmetry splits our parabola, that's the graph, equally on the left, and it splits it equally on the right. Okay, so our axis of symmetry, we usually write it in with a dotted line. So think of it, our axis of symmetry is going to split our parabola into the left side and the right side. So before we do that, before we find the axis of symmetry, and I show you how to do that, let's look at the leading coefficient, okay? Leading coefficient is just your A value. Okay, so if you look in my standard form, what's my A value? Your A value is 1. So my leading coefficient is 1. All right? And this is going to help us determine something later. Okay, so it's a positive 1. So how do we find the axis of symmetry? Okay, there's multiple ways, but one way to find the axis of symmetry is using your roots. Okay, these roots we can use by splitting them evenly. So if you look, if I jump from one root to the other, so this works only if you have 2 roots. So if I count the jumps from one root to the other, I have 1, 2, 3, 4. I have 4 jumps. So how can I split these jumps evenly? And the answer is pretty simple. Since it's 4 jumps, I'm going to split them right in half, which is going to give us 2 jumps on either side. So if I split these right in half, I need the same amount of jumps on both sides. So if I do that, negative 1 turns into our axis of symmetry. Okay, and here's why. 2 jumps on the left side. That's the same amount of distance from the axis of symmetry. and 2 jumps on the right side. So the axis of symmetry will split our roots the same amount of distance from the axis of symmetry. So that tells me my axis of symmetry is going to be 1. Okay, so let me erase these blue lines real quick. Okay, so my axis of symmetry is an equation. It's always x equals to the vertical line that splits. So if you look, my vertical line goes through what x number? It goes through -1. So my axis of symmetry equation is x equal to -1. So as a reminder, sorry, I put that in the wrong spot. Sorry, guys. Our axis of symmetry is x equal to -1. Okay? So what this does is any point on the right side will have the same exact point on the left side. So if you look, we can now answer the point symmetric to the y-intercept. So here's my y-intercept because it's on the y line. I need an exact copy across the axis of symmetry. So I'm going to put this point here. So this point is symmetric to the y-intercept. They are the same distance away from the axis of symmetry. And this point, we've got to put it in point form to answer our question, is -3, -3. Okay, so this is -3, -3. So that is my point symmetric to the y-intercept. The answer here is -3, -3. Okay. All right, so let's go here. Parabola opens which way? So there's 2 options. This is called opening up. Okay, this is when your A value is positive. This opens down. This is a parabola that opens down. This is when our A value is negative. So let's look at our A value. Our leading coefficient, okay? Is it positive or negative? Since it's positive, we know our parabola is gonna look like a happy face. It opens up, okay? And we get that from our A value. So if you look at our graph so far, it looks like it's gonna open up. It looks like this shape, okay? So everything's kind of lining up and working out. All right, I'm actually gonna put the equation of the line of symmetry up here. I just like to label it. All right, so before we answer this question, let's find the vertex. How do I find the vertex? You want to plug in your axis of symmetry, which is x equals into the standard form of the equation. So you're plugging in for x. All right, so in other words, I'm going to take whatever my axis of symmetry is. Remember, it's always x equals. So I'm going to take -1 and I'm going to plug it in for x here and solve for y. Remember, this guy is just y. So let's do that. Okay, let's do that work up here. So it's y equals, and I'm just going to write the standard form. Standard form is x squared plus 2x minus 3. X squared plus 2x minus 3. And I'm going to plug in our axis of symmetry value, which is -1 for x. So this equals -1 squared plus 2 times -1 minus 3. And let's go ahead and simplify this by doing order of operations. -1 to the second power, that's going to equal +1. 2 times -1 is -2. And we have -3 coming down here. And now let's do this math. What's 1 minus 2 minus 3? If we do this math correctly, that gives us negative 4. So in other words, y equals negative 4. Okay? So how do I write that in vertex form? So vertex form, we need our x value and we need our y value. It's a point. Okay? So what do we plug in for x? Well, that's our axis of symmetry. So let's look. Our axis of symmetry was x equals negative 1. So that means our x is equal to negative 1 in our point. So negative 1. And what was our y when we plugged it in? It was negative 4. So our axis of symmetry is 1, negative 4. Okay? So let's plot that point. Negative 1, negative 4 is here. Your axis of symmetry and your vertex, basically your vertex better be on your axis of symmetry. If it's not, you did something wrong. So this is my vertex. And it is at negative 1, negative 4. Okay? So if you look, your vertex is basically where your parabola starts from. See how we have the left side of the vertex, the right side. Here's my axis of symmetry. If I connect these dots, you get the shape of your parabola. Okay? So now we can answer this. Is this a minimum or maximum point? Well, the vertex, is it at the bottom of the parabola or is it at the top of the parabola? Okay? Since we have a positive parabola, your vertex is going to be at the bottom. All right? So this is considered a minimum vertex. All right, so now we have the equation number 2 in factors form. We want to turn it into standard form. To do that, pretty simple. Anytime you have equation into factors form and turn it into standard form, all you have to do is multiply. So if you look, I'm going to multiply this out. So it's going to be 2x times 2x. All right, that gives me 2x squared, 2x times 1, positive 2x, negative 1 times 2x is negative 2x, negative 1 times positive 1, that's negative 1. Combine like terms, these x's in the middle actually cancel out. So what I'm left with for standard form is this. We have f of x, because we have it in function form, equals to 2x squared minus 1. Okay, so simple multiplication. All right, x-intercept, if you remember, we just got to solve for this. So we are going to split this guy up. Once it's in factored form, that's when we can solve. Split this guy up, set him equal to 0. So we have 2x minus 1 equal to 0. 2x plus 1 equal to 0. And solve. So we're going to add 1. 2x equal to 1, and then divide by 2. X equals 1/2. That's one of them. So here we're going to subtract 1. So we have 2x equals to negative 1, and then divide by 2. X equals to negative 1/2. But recall, we want to put these into point form because we're looking for x-intercepts. So in point form, we're going to have 2 of them. So my x-intercepts in point form are going to be 1/2 for my x value, and then x-intercepts always have a y value of 0. The other one is negative 1/2 with a y value of 0. So let's plot those. 1/2 comma 0. So 1/2 comma 0 is right here. And negative 1/2 comma 0 is right there. Okay. Y-intercept, Well, y-intercept is the opposite. Instead of y being 0, we're going to put x equal to 0 into our original or our standard form function. So we have y, so we turn the f of x into y equals 2, and instead of x, we're plugging in 0 to find the y-intercept. Okay, so let's do this math. 0 squared is 0. So y equals 2 times 0 minus 1. 2 times 0 is 0. Y equals 0 minus 1. So y equals negative 1, which means y-intercept is always in point form. We plugged in 0 for x, so our x is 0 and our y is negative 1, and it should be on the y-axis. So 0, negative 1 is right here. Okay. So before we answer this, we want to find our axis of symmetry, but let's just go down the list. So we can skip this like we did before. Our leading coefficient, what is our A value up here? And our A value is 2. So our leading coefficient is our A value, which is 2. Okay. Axis of symmetry. Remember, to find axis of symmetry, we're going to be using the roots. That's one way. So if you look at our roots, from one root to the other, how many jumps is it? If you look at this thing, it's one full jump, right? Because we're at the half. So that means if I had to split this jump, or split them evenly, they're basically doing half jumps evenly. So that means to split these two roots, the axis of symmetry is actually right down this line here. And hopefully you can see that, okay? So we want to split these, which makes our axis of symmetry right down this line. Okay, so that means our axis of symmetry in equation form is x equals, and then where does it go through on the x-axis? It goes through 0. Okay, so our axis of symmetry is x equal to 0. All right, so that's using the graph. If we did not have the graph, there's actually another way to do this. The formula for axis of symmetry is this, negative b over 2a. This is the second way that I wanted to show you. Where does the negative b and the 2a come from? It comes from what we've done before. Remember our a, b, c? So if you look at original equation, this is my a. My b value is not there, it's 0. C is negative 1. So if you recall, here's my a. My b is gone, but there's my c. So if I had to label these, my a is 2. My b, since it's not there, is 0. And my c is negative 1. So I would then plug this information into the axis of symmetry formula. So if I did that, we would get this. Again, this is a second way of doing it. If you don't have a graph, this is how you would do it. And we'll get into more detail here. So we have negative, and what's my b value? It's 0 over 2 times a, which is 2. And if we did this math, we get x equal to 0 over 4, which means x is equal to 0, which we got. Okay? So that's where another way we can get our axis of symmetry through the equation using the a, b, and c value and plugging it into this formula. Okay? So now, since I know the axis of symmetry, does my y-intercept have a point symmetric to it? So here's my y-intercept. Is there another point that crosses or reflects over the axis of symmetry? Kind of like how this reflects over this. It's a copy. Can I copy this over the axis of symmetry? And the answer is no, because it is on the axis of symmetry. So there is none here. There's no point to reflect because my y-intercept is on the axis of symmetry. All right. Does it open up or down? We look at the A value. If it's positive, we have a graph opening up. Okay. So it opens up. If it was negative, it would be a sad face or opens down. But since it's positive, it opens up. It's a happy face. All right, vertex. So once we have our axis of symmetry, which is 0, to find the vertex, we plug in our 0 into our x and solve for y. So let's do that. We have y equals, again using standard form, instead of x, I'm plugging in 0 because that is my axis of symmetry. Minus 1 here, and then let's do this math. Okay, so we have 0 squared, 0, so y equals 2 times 0 minus 1. 2 times 0 is 0, so y equals 0 minus 1. 0 minus 1 is y equal to negative 1. So now that we have our y value, the vertex is our x value from the axis of symmetry. So our x value is 0. So it's 0. And our y value is negative 1. This is our vertex. Here's our x value from the axis of symmetry and our y value when we plugged it in. So our vertex is 0, negative 1. So let's plot that point. 0, negative 1. If you notice, it's already there. It so happens to be our y-intercept as well. So this is not only our y-intercept, it's also our vertex. Remember, your vertex is, think of it, where does my parabola come out of, okay? So I'm going to connect these. As you can see, our parabola has that shape. Now, is my vertex the lowest point of my graph, or is it the highest point of my graph? Since it's at the bottom, that's called a minimum. Okay, hopefully this helps and you're good to go. Let me get you the check-in code and get you out of here. Stay on if you have extra or questions or anything you need more explaining. Okay.